Hi, grade 10 students. Our lesson today is to solve system of two equation, two unknowns with using substitution method. We said that a system of equation within two unknown, each equation is an equation of a line of the form ax plus by equal to c, or can be written as y equal mx plus b, where m is the slope and b is the y-intercept. So what I'm doing now, I'm going to find the common point if exists between these two lines. So as we said in the video of the addition method, you can refer to it for further details. So here I'm going to move fast because here it's a repetition and it's in the first video of addition method. Two lines, either they are intersect, in that case it's called consistent system with one solution, or they are the same line, the two lines coincide overlapping. We have in that case infinitely many solution. It's called consistent system with infinitely many solution. It's of the form 0x equal to 0. Or the lines are parallel, so no points of intersection, so no solution. It's impossible. It's called inconsistent, and you're going to get 0x equal to b. So for further information, you can go to the addition method where the introductory for both is the same. So you can go to the addition method video. You can look at it more. It's more detailed. So let us go direct to examples. But before, let me put the step to solve two equation within two unknown using substitution method. We have four steps. We're going to solve for of one of the equations for either x or y. For example, x equal something. We put it in the other equation, and in that case, we solve for this new equation for the variable. Once we get the variable, we replace it back in the other equation. So to understand it more, we need examples. So let us start by example number one that we have here. I need to solve this following system using substitution method. First of all, first thing I look for, if I have a variable with coefficient 1, like here x plus y, both are variable with coefficient y here and the 1 here and here. So better to solve for x or for y. So let us pick in this example for y. So if I want to solve for y, so I take x to the other side. I have y equal 5 minus x. So y is now 5 minus x. So step 2, this 5 minus x, I replace it by in the first equation by its value. So instead of saying 2x plus 3y, I say 2x plus 3 into its equality of y, which is 5 minus x equal to 5. So in that case, we're going to get 2x plus 15 minus 3x equal to 5. So as I said, step 3, I solve for x. So what is x now? 10. Since x is 10, I take this 10, x is 10. So either I replace it in the first or in the second. So in that case, or I replace it here since x is 10. So what will be 5? Y 5 minus 10. So I get y equal to minus 5. So the two lines intersect any point whose coordinates 10 and minus 5. Let us see it on the GeoGebra program where we're going to graph these two lines and we're going to check the intersecting point. GeoGebra, you can download it from online. It's a free of charge. Anybody can download it. So let us put the first equation. You have 2x plus 3y equal to 5. This is the first line. The second line, x plus y equal to 5 also. As we can see, we have a point of intersection. And if you're going to find the intersection, we write intersection between object and object. The first one is F, and the second one is G. And the point of intersection that we found was 10 minus 5. So now let us go to another example. Solve similarly. Here you can see I don't have a coefficient with the 1 in the 4. Here you have 2, 3, minus 3, 2. So the best way, according to my point of view, I pick to solve for x in the first and in the second. So let us say here I want to solve for 2x. 2x will be 4 minus 3y. X will be 4 minus 3y over 2. I solve for the second also for x. Minus 3x equals 7 minus 2y. So x will be 7 minus 2y over minus 3. We all know that x equal to x. Since x equal to x, I put its value, replace its value here, and the second one, its value here. So I have a system of, I have an equation with one variable. If I equate the two, since x equal to x, so these two quantities are equal. So I do cross multiply, minus 3 into 4 minus 3y equal 2 into 7 minus 2y. I solve, I expand distributive property, I get y equal to 2. Now, since y equal to 2, I replace it either here or here to get x. So 6 to the other side minus 6. So minus 2 over 2, it is 1. So the point of intersection is minus 1, 2. If you want to check it on the GeoGebra, let us do it. So I have another equation. The first one was 2x plus 3y equal to 4. The second line minus 3x plus 2y equal minus 15 equal to 7. Intersection between object and object f and g. I'm going to get f and g. I'm going to get the point minus 2, 1, 2 that we have found in a while. Let us go to another example. Here also the same. I don't have any coefficient with x, so I pick either x and y. If you want to pick for the first, so 5 plus 3y over 2, the x. Here, if you want to solve for this one, it will be 5 minus 9y over minus 6. You can multiply up by minus 1, down by minus 1, and get rid of all the negatives. If you equate it, you do cross multiply, and then you put the variables on one side. And I mean here, if you bring the y to one side and the numbers to the other side, you're going to get 0 equal to 0. What does it mean 0 equal to 0? So the two lines are overlapping, so have infinitely many solutions. Let us check it on the GeoGebra. I have the first equation of line is 2x minus 3y equal to 5. And the second line, minus 6x plus 9y equal to minus 15. So as you can see, these two lines are the same. So I have f and g to the same line. So I have infinitely many solutions. So if you want to put intersection between the two lines, we have a question mark. It means we have infinitely many. So let us take the last example. Here the same story. Because all coefficients are not 1, so I can say x equal 5 plus 3y over 2. Here the same, 7 minus 9y over minus 6. If I equated, but after distributing, put y on one side and x on the other side, I have 0, 18y minus 18y equals 0, equal minus 16. So it's impossible. What does it mean? No solution, and the two lines are parallel. So if I want to check it also, to see what happened. So let me put the first line, which was 2x minus 3y equal to 5. And the second line, minus 6x plus 9y equal to 7. As you can see, the two lines are parallel. If you search for intersection, we don't have between object f and g. So come in, it's at the same, we don't have any output. So it means the two lines are parallel. I hope that you enjoyed that video and you got my point, how to solve a system of two equations using substitution method. See you on Monday in class.